National Electrical Code Article 300.3b states that conductors of different systems, circuits, or classes of voltage shall not be placed in the same raceway, cable, or enclosure unless otherwise permitted in the code. Exception No. 1 provides an allowance stating conductors of systems and circuits of any voltage may occupy the same raceway, cable, or enclosure if all conductors are insulated for the maximum voltage of any conductor within the enclosure. Exception No. 2 states conductors of Class 1 and Class 2 circuits may occupy the same raceway, cable, or enclosure as conductors of any other class of circuit provided that the conductors of the Class 1 and Class 2 circuits are type FBLP or type FPL or of an approved type having equivalent performance. Exception No. 1 applies to the case where multiple motor control centers, or MCCs, are fed from a common source and the conductors are all insulated for the same voltage. Exception No. 2 does not apply to this case as the circuits are not Class 1 or Class 2 circuits. Therefore, Article 300.3b prohibits running conductors from two separate MCC in the same raceway unless an exception applies. While the National Electrical Code does not specifically address backfeeding, it is a potential hazard that should be addressed. Installing interlocks and a motor control center main breakers can prevent one motor control center from backfeeding another. Using separate raceways for each motor control center would eliminate the potential for backfeeding. If the conduits are close together, it is possible that a fault in one conduit could damage the other conduit, resulting in a backfeed condition. Based on the National Electrical Code requirements and the potential safety hazards, it is not recommended to run conductors from two separate motor control centers in the same raceway. Using separate raceways or implementing interlocks would be a safer and code-compliant solution. A raceway is defined as an enclosed channel designed expressly for holding wires, cables, or busbars, with additional functions as permitted in the National Electrical Code. Raceways can be made of metal or insulating material. The definition excludes certain enclosures, specifically an enclosure for switches, circuit breakers, fuses, controlled devices, and similar equipment is not classified as a raceway. Backfeeding refers to a situation where electrical power flows in the reverse direction of its intended path. This can occur when a generator or other power source is connected to a circuit in such a way that it sends power back into the utility grid or another part of the electrical system. Backfeeding can be dangerous because it can energize circuits that are normally de-energized, creating a risk of electric shock or equipment damage. It can also interfere with the operation of protective devices such as circuit breakers and fuses, and can potentially overload the electrical system. In the context of motor control centers, backfeeding can occur if two or more MCC are connected to the same electrical system and one MCC is energized while the other is not. If there is a fault in the de-energized MCC, the energized MCC can backfeed power into the faulty MCC, creating a hazard for personnel working on the equipment. There are several ways to prevent backfeeding. Firstly, interlocks in the MCC main breakers can prevent one MCC from being energized while the other is de-energized. Secondly, separate raceways for each MCC can prevent a fault in one MCC from affecting the other. Thirdly, properly sized and installed overcurrent protection devices can help to limit the amount of current that can flow in the reverse direction. Interlocks are safety devices that prevent a piece of equipment from operating under certain conditions. In the context of motor control centers, interlocks can be used to prevent one MCC from being energized while the other is de-energized. This can be accomplished by using a mechanical interlock that physically prevents the breakers from being closed simultaneously, or by using an electrical interlock that prevents the control circuits from being energized unless certain conditions are met. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. These devices will automatically trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the equipment. In the context of backfeeding, overcurrent protection devices can help to limit the amount of current that can flow in the reverse direction, reducing the risk of electric shock or equipment damage. It's important to understand conductor insulation ratings. The insulation rating of a conductor indicates the maximum voltage that the insulation can withstand without breaking down. Conductors used in electrical systems must have an insulation rating that is equal to or greater than the voltage of the circuit in which they are used. In the context of sharing a raceway, National Electrical Code Article 300.3b exception No. 1 allows conductors of different systems to share a raceway if all conductors are insulated for the maximum voltage of any conductor within the raceway. This means that if you have two circuits in the same raceway, one operating at 480 volts and the other at 208 volts, all of the conductors in the raceway must be insulated for at least 480 volts. Using conductors with the appropriate insulation rating is essential for safety. If the insulation rating of a conductor is too low, the insulation can break down, creating a short circuit or ground fault. This can lead to electric shock, fire, or equipment damage. It's also important to ensure that the conductors are properly installed and protected from damage. Sharp edges, excessive heat, and exposure to chemicals can all damage the insulation and reduce its effectiveness. Regular inspections and maintenance can help to identify and correct any potential problems before they become a safety hazard. In addition to the NEC requirements, there may also be local codes or regulations that apply to electrical installations. It's important to check with the local authorities to ensure that your installation complies with all applicable requirements. Proper grounding is also crucial for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip over current protection devices and prevent electric shock. All electrical equipment should be properly grounded in accordance with the NEC and local codes. When working on electrical equipment, it's essential to follow safe work practices. Firstly, always to energize the circuit before working on it. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, never work alone. Fourthly, be aware of the potential hazards and take steps to mitigate them. Motor control centers are essential components of many industrial and commercial electrical systems. They provide a central location for controlling and protecting electric motors, and they can also include other electrical equipment such as transformers, circuit breakers, and control panels. Proper design, installation, and maintenance of motor control centers are essential for ensuring the safety and reliability of the electrical system. Firstly, MCC should be installed in a clean, dry location with adequate ventilation. Secondly, the MCC should be properly grounded and bonded to the electrical system. Thirdly, all wiring and connections should be properly sized and installed in accordance with the NEC and local codes. Fourthly, the MCC should be regularly inspected and maintained to ensure that all components are in good working order. Firstly, check for loose connections, damaged wiring, and corrosion. Secondly, test the operation of the circuit breakers and other protective devices. Thirdly, clean the MCC to remove any dust or debris. In addition to the technical aspects of electrical safety, it's also important to consider the human factors. Electrical work can be dangerous, and it's essential to have qualified and experienced personnel performing the work. Personnel should be properly trained in electrical safety and should be aware of the potential hazards. They should also be provided with the necessary tools and equipment to perform the work safely. Safety meetings and training sessions can help to reinforce safe work practices and keep personnel informed of any changes in the electrical system. Regular audits of the electrical system can also help to identify any potential safety hazards. In summary, National Electrical Code Article 300.3b addresses the installation of conductors from different systems in the same raceway. While it generally prohibits this practice, exception No. 1 allows it under certain conditions, specifically when all conductors are insulated for the maximum voltage of any conductor within the raceway. Backfeeding, a potential hazard not explicitly covered by the NEC, can occur when power flows in the reverse direction. To prevent backfeeding, measures such as installing interlocks on MCC main breakers and using separate raceways for each MCC are recommended. It is imperative to adhere to safe work practices, use appropriate personal protective equipment, and ensure that all electrical work is performed by qualified personnel. Proper grounding, regular inspections, and adherence to local codes are also essential for maintaining electrical safety. Furthermore, regular inspection and maintenance is needed to guarantee the effectiveness and safety of the motor control center.